I'd like to welcome everyone to today's mini lecture. Today we will be discussing percent compositions. Oftentimes in chemistry, we are asked to find percentages. Sometimes we're saying the percent yield, sometimes it's the percent error, sometimes it's the percent composition. But often, whenever we see this, we think that it's a lot of different mathematical formulas. But in actuality, we have one formula that we can use. Any percentage is always going to be found by saying part divided by whole times 100. So let's say that I wanted to know what is the percentage of male students to female students in this classroom. Very easily, I could just go through and count all the number of students in the classroom. The total number of students, that would be the whole. Then I could go back in and count just the number of male students or just the number of female students. That would be the part. Divide the part by the whole, multiply it by 100, that would give me my final answer, which is a percent composition. Now, the reason that we multiply it by 100 is that in math, we keep everything in a base of 100. All of our percentages are 100. So we just have to multiply it by 100. So how does this relate to our chemistry unit? Well, let's go back and let's look at a little bit in nomenclature. So before I can determine what this percent composition is, I'm going to need to know what is the chemical formula. So I have copper, Roman numeral 1, chloride. So when I see this, I'm going to go back and use my notes. So I have them memorized right now. I have IDE, so that means it's binary. So that means I'm going to be using a metal and a non-metal. Then over here I have copper. Now that metal, very special metal, it is a transition metal. So that Roman numeral 1 tells me its oxidation number. So the very first thing I need to do is to write the formula for my copper, and that's Cu. The next thing I'm going to do is write the formula for my chlorine, Cl. I'm going to use my periodic table, I'm going to use my rules, and it says let's add in our oxidation numbers. So copper is positive 1, and chlorine is always negative 1. So when I crisscross, I get a 1-to-1 ratio. So in this particular example, I get CuCl, and that's going to be my actual formula. They're not asking for the formula, they said what's the percent composition? So I'm going to go through, just like we've done in the past, trying to do that molar mass. I need to know what is the mass of this compound. What is the molar mass? So I have 1, and I'm just going to put 1 copper, and I need to look at my periodic table, and I see that that 1 copper is 63.6, so I'm going to put 63.6. My chlorine, I have 1 of those, that's 35.5. So now I get a 1, an 8, 9, and a 9. So when I look at this, I can see that my total mass is 99.1, and the partial masses is 63.6 and 35.5. So if I want to do the percent comp of copper, then I would just simply say 63.6 divided by 99.1, multiply all of that by 100. So the percent comp of the copper is going to be, and I'm just going to grab my calculator, go through it, 63.6 divided by 99.1 times 100, I get 64 point, and then I get 177, but it rounds off to 1/8. We always use 2 places to the right when we're doing percentages because that puts it in a percent of 100. So it's 0.18. All right. So if you know that, then we can go back in and now calculate what is the percent composition of the chlorine. So I can do the same thing, and I can just simply say the percent comp of the chlorine is going to be 35.5 divided by 99.1 times 100. Now some of y'all are pretty good with the math, so you already figured this out. If I'm going through and I only have two numbers, and by having these two numbers, for copper and for that, it has to add up to be 100. So I can just simply say 100 minus the 64.18, come up with my answer. Or it's just as easy to punch in 35.5 divided by 99.1 times 100 is 35.82. So I'm going to put 35.82%. All right, so that was the first example problem. So the next example problem gives us something that we've not seen before. So I don't want you to panic. Still going to be handled very much the same way. Do you see how I have sodium carbonate? So it's going to be Na2CO3. They give me the formula, but what you haven't seen is this little dot. In math, that means you're multiplying it together. But in chemistry, it means that this water molecule must be present for this to form a crystal. So this is an ionic compound, but it won't form a nice pretty crystal unless it has water present. These are called hydrates. So the question is what is the percent of water in this hydrate? So I'm not asking for a percent of an individual element now. I want to know what is the percent of water. So the way that I would address this is still the same. I'm going to say, okay, my NAs, I have two of them. And sodium, I need to check one more time. Sodium, Na is 23. So I'm going to say times 23.0, which is 46.0. I have one carbon, don't want to make any mistakes, which is 12.0. I'm just kind of lining them up. And I have three oxygens at 16.0 apiece for a total of 48.0. So when I come up here, I'm going to add these three together, and I get 106. So that is going to be the mass of just the Na2CO3. But guys, that's not the whole. I need the whole mass. So I know that H2O, if I say I have two hydrogens at 1.01, is going to be 2.02. And then I have one oxygen at 16.0. Add these together, I get 18.0. So what I can do is I know that one water, H2O, is 18.0. Well, how many waters do I have? Right, that's that big coefficient number right there. I have 10 waters. So all I have to do is say 18.0 times 10, and I get 180. So now if I add 106 to 180, hold on just a second, and then I get 186. You say, well, what is that? That is the total mass. That's the whole thing. So if I'm trying to find the percentage of water, then it's nothing more than the part. What's made up by water? 180 divided by 186. And all of that is going to be times 100. So when I do this, this will tell me mathematically what my actual answer is. So I'm going to say 100 that should have been 286. Thank you. Almost made that mistake. So that is 286, not just 186. If you didn't see that, I just made a mistake and added them. That should be 286. So now when I say 180 divided by 286, I end up with 62.94%. All right, I like that. So I hope that you could get the same answer. And there is one more that I would like to do as well. So this is the third one. And that I hope you're putting these in your notes. So this one's a little different, but I don't want you to think that it's any more difficult or anything. It says we have a compound that contains 29.58 grams of magnesium and 86.42 grams of chlorine. What is the percent composition of the element? Well, guys, of each element. Let's just say that we don't know what the final compound is. Like over here, we had the compound here, or we had this one because we had the name. All I know is I have two elements that make this up. So what I'm going to do is I'm going to use the numbers that they have. I know that in all of chemistry, that anytime that I add two or more elements, I cannot create or destroy matter or energy. That's a law of conservation of matter. So if I started with so many grams of this and so many grams of this, I can determine how many grams I'm going to get. How? Just simply add them together. I have 29.58 grams plus 86.42 grams equals, and I'm going to have to use my calculator to make sure I don't make a mistake. It says 29.58 plus 86.42. I get exactly 116. So now I know that my total mass, even though it's not looking at the molar mass, I know that it still has to be a ratio that is going to be the same ratio as our coefficient numbers in a formula. So I'm going to come back in and get the percentage. So the percent of this one, which I'm talking about magnesium, is going to be 29.58 divided by 116 times 100. So my percent of magnesium, and all of this is again based out of 100, says that I have 29.58 divided by 116 times 100, I get 25.5%. Awesome, awesome, awesome. So now if I do my percent of chlorine, I'm going to end up with 86.42 divided by 116, and again times 100. And that will give me, and when I punch it in on my calculator, I'm going to get 74.5%. So guys, just a little recap, okay? Number one, if you're given the name, you have to write out the formula. Get the formula written correctly. And then we're going to use our molar mass in order to determine the overall percent composition. Sometimes we're given formulas, and in this particular one, we were given two formulas that act together to form a total compound. This one had a mass of 106, and this one had a mass of 180. The question says, what is the percent composition of the water? So I just take my part being the water, 180 divided by the whole, 286. That gives me the composition. And finally, what happens if you have a balanced equation or you know that they're going to add together to a total? And all I have to do, no molar masses involved at all, just use the masses that they give me to begin with. They have to be in the same ratios as my actual formula. So whenever I do this and I do my part divided by whole, I will get the same percentages, 25.5% and 74.5%. So I hope this has helped you. Make sure that you complete these and put them into your notes in your digital notebook, and then we will have some additional problems to do as well. Thank you.